to do regression, right? The next thing that you have to do is correlation. Sometimes you do it before. So correlation gives you an idea of how all your values related. So, for example, if you plot up and you get your values like looking like this, right? These values here are correlated positively, right? And the largest possible correlation, the largest possible, so that like the max for a positive correlation is 1. If I give you something like this is a negative correlation. Once your value is shaped like this or your best fit looking like this is a negative correlation and the maximum value is -1. So a positive correlation, you might remember it as being directly related. A negative correlation is what we call something inversely related. Inversely, everybody? Yeah. Right? And then, of course, we have no correlation if our values look like this. Right? No correlation. Right? This is no correlation. Right? So technically, our correlation value, the symbol that we use is R. Our R value lies between -1 and 1. Right? Whenever you see -1, whenever you see -1, this is very strong, right? -1 is very strong. Anything close to 0 is very weak. So these are the things that we need to know about correlation. And of course, we need to be able to calculate correlation. I want to show you the formula in the, I think I didn't show you it last week. I want to show you the formula from the answer booklet, so you'll be familiar with that version. Right. So if you look here, this is the next formula that you can use correlation. Right, this one down. Right, it's also called the product moment correlation coefficient. Right, so that R value there. Write that formula down. That's the one that you will see in your summary, in your formula sheet in exams. Right, that's one version there. And there's also the next version I'll give you here. It looks shorter, but it simplifies to the same thing, right? Sum of xy over sum of x, sum of y. Right, so you can write that version in red. I think I gave you those things last day as well. Kubisha, finish up here now. Yeah. All right. So let's do one calculation. I'm not gonna make it do the whole long table as last time. What I'm going to do, I will give you using this formula here. I'll just give you some of the quantities, right? Diane, thanks for joining class. Right, so I want you to find R given the sum of X is 680. The sum of Y 996. The sum of X squared is 20,154. Sum of Y squared is 34,670. Sum of XY is 24844. 24844. There's a 7 here, right? 34,670, 24,844, and it's 30. All right, so use those values, plug it in your formula, tell me what you get for R. And tell me what type of correlation it is. Positive, strong, positive, weak, negative, strong, negative, weak, right? Strong is like anything above 0.7, 0.8 around there. Then you have weak, and then you have like very weak. Tell me what you get online, you'll get message about it, right? Right, remember your value should always be less than 1 or more than, sorry, between -1 and 1, right? What answers we got so far? Okay. Helen, check back yours there. Babisha, Alina, or y'all got?
Like 2 more seconds, please, sir.
All right, go ahead. Alina. Yeah, you can join when, but. Right, good. 0.8 is nice. So technically, all we're doing here, we're just plugging in the values, right? So the value here with 30, the sum of xy, I gave it that as 24,844. Then you minus the sum of x, which is 680, the sum of y, which is 996. Right? And then you divide all of that by the square root of inside here. So technically, you can put out all. Everybody go here. Let's look at my answer. Yeah. Right? The square root of n, which is 30. I'm blocking him. 30 by the sum of x squared, which is 20,154 minus the sum of x squared. There's a square bracket here. Minus the sum of x squared, where sum of x is 680 squared. You close that bracket, then you open up the next bracket. 30 by y squared, which is 34,670 minus sorry. 34,670 minus. Where is it? Where is the sum of y? Right. Minus 996 squared. Close bracket. Square root of all of that. And you should get 0.8. Right? So I wouldn't say very strong, but you can say strong positive correlation. Okay. So that's a strong positive correlation. Very strong and near perfect is equal to 1. Right? You got that value. Ravisha? Right? So the trick is just plugging in the values, right? If they give it like this, you use this formula. Otherwise, if it's Sx and Sxy, you're using the next formula I gave you. All right, so we're gonna attempt some full fast papers on these topics now. Right, and then we're done with this. Write it up. Any questions there? Okay, taking it up, right? Hold on, eh? All right, that's 2021, right? But I have nothing in it. Russian didn't come that year. They'll give you a straight high positive testing on thing. That's a bad year. All right, this copy real blurry. Can we all can read that, right? Did this one last it? This 2022. I know it's a little blurry, but the first part is to find the gradient. We didn't do this last day, right? You know how your notes. Anybody who have the notes, did that check and see we did this one? This is 2022 number 6. No, we didn't do it. Okay. Start here now. X is ours. I know it real bad. It's a bad copy, right? Sorry. Right? Y is scores. So training times and it scores that again. So see how the best they can make out now. Find the gradient. So like I say, find the gradient. What do you mean? What do you really want to find? When they say find the gradient, what y'all think they mean? Find the straight line now. Now the whole thing. All they want you to do when they say find the gradient, remember equations of the form y is mx plus c. Right, yes, the coefficients, yes. So that'll be y is equal to bx plus a, right? So they want you to go back and find b. Right, because b is the gradient. Right, so you can go back to the formula from last day and work on p. Check in the group. In the group, the formula sheet. It's not the formula sheet. That's all I get it now. Work it out. Tell me what you get. Once you get it right, you move it on one time. Go to this, go to the answer. Okay. Sorry, the formula sheet.
Say what's the value of y squared?
Y squared. Like 69.82.
Okay.
Somebody can just share back the formula sheet in the group now, please. There you have it. I can send it. No, not this summary, the formula sheet. Don't have it. I don't have a phone anymore. Take a picture. Let's take a picture. I just want to get message values and then we're moving on, right? Dario, an excuse. Can you send an answer, please? Right, x squared looking like 19359, yeah? X squared gonna have a point. 19359. X squared gonna have a point. Right, I've seen some values coming in, Keelan, Christopher, yeah, we're just waiting on Darian now. Once we get Darian, we good to go. And Lobisha, well, she cannot respond to the class already, might be an answer. Lobisha, we get a value for next class. Now you respond once to the class already. Yeah, an error, or they're making an error, that's why. Or next class will be said, okay, all right, well, at least you respond twice, huh? Technically, you respond twice, Right, before I go to the code, let's just see what they ask for after. They ask for the intercept, so find E one time. And then interpret the gradient in context of the data. Right, so find your E, that's the y-intercept, and then explain what the gradient represents. I just give you 2 minutes and then I'm going on the board and work it out. But you're gonna check it back, right? What you got for sum of x? 311. What you got for sum of y? What you got? 18.6. All right, so let's come and see what we got here, right? So I just have the formula down and I put in the sum of x, the sum of y, and here will be the sum of x squared. When you plug this in, what you get? Right, 0.188. But that's a b value. Now to get the a value, what we're using a little formula, y prime minus b by x prime. We didn't technically work out y prime as yet, so I'm working it out here. 18.6 over 5 values, right? Right, minus b, which is 0.188 by x bar, which is 311 divided by 5 values. Right? And then we take a look at what does that mean? What you got here? Oh yeah, now did white number. Now you got it, so you get error. Diane, you got value here. I get minus. I get minus 7.97. What do you get? 18.65 divided by 5. I get negative 7.97. So my equation would have been my equation is y is equal to 0.188x minus 7. Let's see if anybody else get up. I'll see why it's minus. 0.91. Anybody get something else? What else y'all got for E? I'll do it over, yeah, I want to make sure. I got that minus value, which is kind of weird. 0.188 by that's 11. Yeah. Yeah. It's about that minus 7.97. Okay, nice. And the next part they ask for is they ask what does B represent? So here's what B said. For every unit change in X, right? For every unit change in X, right? So what Y gives us is the factor B gives us the factor that Y will change by, right? So basically, for every unit change in X, Y will increase by this particular factor here. Right, so for every unit increase in this Y value will go up by this factor, by the factor B. Okay. Right, let's go again. Next one. Whatever the year that we just did was 2022, 2021 have none, right? I think we did 19 in class. I remember doing 1 in class. I feel it was 19 because it's still showing up here. Anybody made a note? It was 19. Yeah, that was the one with 39.2 plus 10.9x, they gave you the equation and you have to interpret it. Right, I'll show you again. Just in case we didn't do it, right? This is 2019. Try this here, and then we talk about the correlation value. No calculations really here, except with the small estimate. Try that fast, please. What does 10.9 represent? I remember doing one like this last week. 10.9 represents the same thing, right? It represents the factor by which y will increase when there is a unit change in x. Okay, same similar definition, right? I wanted to change the definition. Use the regression line to estimate y when x is 3.5. So all you have to do here, is take 39.2 plus 10.9 multiplied by 3.5 and you'll get the y value. What is that? Say 9.2 plus 10.9 by 3.5. 77.35. So the estimated value for y is 77.35. Right? Remember, I told you that one of the uses of linear regression is to be able to estimate, right? And last part, that R value is 0.9926. We have to say what it means, right? So let us pick on somebody who didn't answer now. We'll be sure. Let's see if we can get three responses, sorry, in one class. Ravisha, how will you interpret that R value? 0.9926. What would you say? You get that right, we call it up for the rest of the month. You don't have to respond again for the rest of the month. If you get that right. Right, I'm gonna just make a note here, call Ravisha model. Oh, she said something, man. Yes. Strongly positive, yes. So the correlation is strongly positive. It took long, so you just qualified from the exemption pretty much, right? All right. Let's go again. Let's go to our old next one. Hold on, give me 1 second. You just copy a little better. Some years it will be a regression. Yeah. These years is okay. That's not 1 second here. Really. In 2023, they gave us a lot of work, right? Where do the regression and the correlation. So I'll just post the values up and do the whole question, please. Darian, it would be nice if you could do this one, all right? So I want you to find A, B, and R. Although you're not seeing it there, I just zooming in here so you just have the important things, right? Find A, find B, and find R. Okay. If we get that right, we might just do might be almost done. A, B, and R. Take your time and we'll go down. Try that, please find A, B, and then find R. And comment on R. A, B, and R, right? No, it don't matter. Y and X. A, B, and R. Right? How you looking? ABR, okay. Oh, yeah, and it's 12, yeah. That's why they're showing that part there. I sign AB and R. And well, your R should be easy to interpret, right? Because that I think it's a high value. Is that high or low value? You see that's now. Oh, high. Okay, nice. I keep messaging Darian, waiting on yours. Very good, Darian. Good job, Darian. Go, Darian. Good job, man. All right, so not bad from what I see so far. Let me see. So we can move on next. Kaylin should line up next. If you get a visual, we'll be done. If Ravisha send correct answers, we are done. Let's see what they got. Let's wait now, Ravisha. We done. Let's say, take it easy. All right, Ravisha, what you got? All right, so very good. So for most people are seeing, I am seeing, all right. All right, right? But for most people are seeing, we got the same things, right? Y is equal to 0.96 x plus 20.72. Yeah, right here. Hold on. Anyway, I'll just call it out, right? So the value for B is 0.96, the value for A is 20.72, and the value for R was 0.99. That's a very strong correlation, right? That's almost one, a very strong positive correlation. Okay, so to be specific, what I should really say is, I know I zoom out, add a zoom out a little bit, right? But to be specific, what you really have to say is that there's a very strong positive correlation between the number of years of experience and the profit being made. Okay, so you have to be specific on the question. So you shouldn't ideally say for every unit change in something, right? Like if you have to explain B, you should be specific to what X and Y is wants to give you it. So in this case, when they ask you to interpret R, you tell them very strong positive correlation, right, between profits and number of years of experience. Okay. All right. Ravisha didn't answer, so we gotta go again. All right, Solid. We do plenty there. Because they don't have much variation again. There's one X on Y in a earlier year. Right? So the next thing that we have to do I start that now? How long give me? No, wouldn't get all your now. But yes, huh? Try to it. No, I do like what testing. No, I just want to regression. I didn't know about the test. I have to go back to the three methods I estimate. I didn't know any point estimate, confidence, and confidence. I last three things I wrote. So I just want to give you an idea of where we are and what we're doing next, right? So we are at they have full breakdown of module. Anyway, we did the last thing in module. We did the last thing in module. Hold on. Right. Sorry, wrong unit. Right. So we did the last thing in interpreting data, that's the question on it. The next thing that we're going to do is sample distributions. So we're going to do point estimates. That's where you're going to estimate a point, like mean or variance, estimate a point from a sample. And then after we do that, we are going to do something called confidence interval. So we're going to try to estimate mean within an interval. And lastly, we go and do hypothesis testing. So we go and set up hypotheses and test and see which is correct. So those are the three types of testing that we're going to do. Right? And as I said, we already did the last thing there, which is correlation and regression. Right? I wouldn't start the estimate thing now because we wouldn't finish the first thing. So try to envision it like this, right? We're going to estimate mean. And we have three ways that we're going to estimate mean. We're going to estimate mean via point estimates, like an actual point, an interval where it can lie, and then doing a hypothesis test. So there are three ways that we're going to learn to estimate now. Given data. All right, so this is the analyzing part of module of